So today, doing compositions of functions. Writing the composition of a function is similar to evaluating a function for a value, except that another function replaces that value. So basically what you're doing is what we were doing yesterday when we had a value and we plugged it in for x, except this time, instead of plugging in a value for x, we're going to plug another function in for x. So you're taking a function, you're basically stuffing it inside of another function. So we've kind of got two different ways of writing that. So the composition of functions f and g is written as f, our little composition, which looks like a multiplication sign, but it's an open circle instead. So this is composition. This would be your multiplication, right? And you're going to see both of those today. So composition, again, open circle, multiplication, that's solid circle of x, yes. And then the other way of writing it is f of g of x. Notice the g of x is inside the function of f. So it's kind of like literally putting the function of g into the function of f. So again, composition, you're plugging the function of the second function into the first function. Okay, so given that we have f of x equals 3x plus 2 and g of x equals x minus 1, we want to find f of g of x. So what we're going to do is we're going to take the function f of x, which is, we're replacing that x value with the function of g of x. So we're saying f of x minus 1. So we're replacing the x value in the function of f with x minus 1. So we have 3 times x minus 1 plus 2. So again, we just replace the x value with the function of g. And then you distribute it, so we get 3 times x is 3x, 3 times negative 1, negative 3, and plus 2. So then we can combine our like terms, we get 3x minus 1. Then we have find g of f of x. So this time we're taking the function of f, plugging it into the function of g. So we take 3x plus 2 and replace the x in the function of g with that 3x plus 2. Still subtract your 1. Combine your like terms, we get 3x plus 1. So notice the function of f of g of x, or the composition of f of g of x, is different than the composition of g of f of x. Close to the same, but not. Okay, one is 3x minus 1, one is 3x plus 1. So let's do some compositions together. So for these compositions, we've got f of x. It's going to be x plus 3. G of x is going to be 2x minus 1. And h of x is going to be x squared plus 2x minus 3. Okay. And number 1, they say, let's find f of g of x. So we're taking the function of g of x, and we're going to plug it into the function of f of x. So again, the function of f of x is just x plus 3. And we're going to take the function of g of x, and we're going to plug it in for this x value. So when we plug in g of x, we're replacing this x value, function of g. So that's going to get us 2x minus 1 plus 3. Then we want to simplify or plug it in together. We can drop our parentheses in this case. We're not distributing anything across. And combine our like terms. So that's going to get us 2x plus 2 is f of g of x. So let's do another one. Number 2, we're looking for f of h of x. So again, f of x is x plus 3. I'm plugging the equation of h of x in for f of x. So basically, anytime I come across an x when I'm writing this equation, I'm going to replace it with h of x. So f of x is just x plus 3, so I'm going to replace my x with what h of x is equal to, which is x squared plus 2x minus 3. And the rest of f of x is just that plus 3. Combine your like terms. Well, I've got a negative 3 and a positive 3. Those two things cancel out. So f of h of x is going to be equal to x squared plus 2x. So again, all we're really doing is substituting in a different function for the value of x. Number 3, this time we're going for g of f of x. So what function are we starting with? 2x minus 1, right? So I've got 2. I'm plugging in the function of x, or f of x, for my x value. So it would be 2x. I'm going to replace that x with the function of f, which is x plus 3. And continue writing my g of x function. So I've got 2x, going to replace it, minus 1. I've replaced all my x's with my function of f. Now I just need to simplify it down. So I'm going to take 2, got to distribute. So 2x plus 6 minus 1. Combine our like terms. We get 2x plus 5. Number 4. Again, this is just another way of writing it. We've got g of h of x. So we're taking the function of h, we're plugging it into the function of g. Again, g of x is 2x minus 1. So I've got 2x. Replace my x with the value of h of x. So that's going to be x squared plus 2x minus 3. And then continue just writing my g of x function. So minus 1. Okay. Again, I'm substituting in the x value with my other function. So then I want to simplify. I'm going to distribute my 2 to everything on the inside. That's going to get us 2x squared plus 4x minus 6 minus 1. Combine our like terms. 2x squared plus 4x minus 7. Okay. Now number 5. We've got h of f of x. So what am I going to get for this one? What do I start with? X squared. So that means I'm going to square my function of f. So I've got x plus 3. That is being squared plus 2. I've got another x. So I'm going to replace that x again with my function of f. So I've got another x plus 3. And then minus 3. So again, I've replaced all of my x values with my function of f in my equation of h. Now I just need to simplify. Well, I've got x plus 3 squared. So again, you've got to FOIL that. We got x plus 3 times x plus 3. So x times x gets me x squared. X times 3
plus 6x.
Plus 6x plus 9. Okay, so yeah, you went ahead and combined that, gives us that 6x. Then we've got 2 times x plus 3, so distribute 6 and our minus 3. Combine our like terms, we've only got 1x squared, so that just stays the same. 6x plus 2x gives us 8x. 9 plus 6 is 15 minus 3 gives us 12. Okay. Any questions on how to do compositions of functions? Okay.